So, we will optimize. So far we did hardware details, now we will do the software details. So, one thing is, even sequential codes you can get significant speed up by following simple strategies. Okay. Vectorization is one, we discussed it. So, we will just do some of the simple ones in this lecture today. So, we will use Google Colab for all our tests. Okay, it is free, you can run it through your Gmail account. Okay. And so, we can also use GPUs in that, okay, but GPU later. Right now, we are going to use CPU. So, the numbers I tested are with this processor Intel Xeon with CPU 2.2 gigahertz. So, numbers will change if you use different processor, but the trend will remain the same. Okay. And time is in milliseconds, whatever I am going to report is in milliseconds, and there is error around 10% errors. So, you do another run, your numbers will be different than what I get, because they are multi users and many people are using the same RAM, same CPU. CPU different core. By the way, when I run a CPU job in CPU, so there are many cores. So, like this in Xeon processor may have 16 CPUs, 16 cores. So, I am going to use one of them, my core, but these are used by some other people. Okay. So, that will affect our performance. I mean, well, the numbers will be different for different runs. I checked it and the numbers are quite different. Okay. So, this is a one snapshot of a Google Colab thing. It is quite easy. I sent you the programs, and please do run it. You can just do tutorial in YouTube if you like. So, it is very easy, and it is called Jupyter Notebook. So, it is a notebook where you can type your code, and it is basically a notebook. So, you do not need to worry about different files scattered everywhere, and it is in the cloud, it is safe. You can also look at previous versions. So, here you can see all changes saved. So, you just click there, you will see, suppose you made a mistake, then you want to go back to previous version, you can go back. Okay. So, the thing we am going to do is run 1D array operations and 2D array operations. So, operations I am going to work with is sum of two arrays A star B. This A and B can be either 1D array of 10 power 8 units or 2D array of 10 power 4 times 10 power 4. Okay. So, the number of elements are the same for both 2D and 1D arrays. Alright. So, we want to just compare the numbers and see whether 2D there is a loss of performance or same performance with them. And one more thing I am going to do is sum of sine of A. So, I take array A, I compute sine of every element of A. So, there will be another array and sum all the numbers, and I chose sum now in the revised code, because I want to get the same number. Okay, once you generate the numbers, your sum should be the same. So, it is a double check. So, I think there are some strategies you can always use. Maybe your new code is not so, maybe there is some error. So, just use something which gives you okay same number. So, I am happy the code is, at least code is working. So, these are two operations we are going to do for both 1D and 2D in Python now and later in C++. Okay. So, the code I want to do this, please remember sum A star B. So, you will use for timing, right. So, I need to time. So, for timing there is a system function called date time, Python function. Okay. It gives you date and time in hour, minute and second. Okay. So, let us say it took 1 hour, 2 minutes and 3 seconds. So, it will be something like, well, 3 seconds, there are milliseconds also there. So, one output, well, I do not have the output here, but you get colon separates hour with minutes and minutes with seconds. Okay. I have converted them to millisecond here. So, date time is a useful function, it will give you the time at that time. In fact, I found that it is in GMT, no sorry, this is not GMT, I think. Yeah, it is GMT. C++ chrono. Okay. So, it gives a time and you can use it to see what time I ran the code. Okay. So, we start initializing a variable tot, which will keep the total. I am doing the sum, and it is just in loop. The first part is with the loop, which is I range 1 to 10 power 8. Okay. So, this is a function. Okay. I hope everybody knows Python. Okay. So, this is a loop for 0 to 10 power 8 minus 1. Okay. And this a I and v I multiply and put it in total, keep adding incrementing total with that operation, and then I take another time T2. So, I have two timings at T1 and there is a code was ran and T2. So, the difference will T2 minus T1 will be give me the time for execution of the code. Okay. So, that is what I am going to print T2 minus T1 and also print total. So, that I know how much was the total. These are random numbers, I did not put it here, but the A1 and A2 are random numbers, you can see in the code. Okay. So, random dot random bracket will generate this stuff. So, this is one operation. So, by loop, this is using loop. Another way I can do it by just doing vectorized operation. A star B will give an array. By the way, A star B does not mean column versus row versus column multiplication like in physics. It is element by element multiplication. So, in fact, this is what we do in Python is we take two of them and element by element multiplication, this with this, this with this, this with this, and you create another array. Okay, here. Now, this A star B will generate this array, we do not need to store it elsewhere, you can just do it in the fly, and this function np dot sum, np is numpy. Okay. So, np I import numpy as np. So, np dot sum A star B will give me the total, is one line, the code is simpler, it will be error free, because I mean when I do a loop there is a temporary variable I, colon may be missing. So, these vectorized operations are simple to write and it turns out is quicker as well. So, again I time T1 and T2 and print the difference. Now, output I have not written it here, when you run your Google Colab you can see the output yourself. Okay. So, the C++ we will do in a minute, well not in a minute, but 10 minutes later, but let us look at the Python numbers. With loop it is 30,910 millisecond, that means 30 seconds, get 30.9 seconds. Okay, it is a big number, but vectorized operation is only 473 seconds, 473 milliseconds, these are all in milliseconds. So, the ratio is around 100, okay, 80 or something, right. I mean 30910 divided by 473, you can look at the number is around 80. So, vectorized operation, this one line operation is 80 times faster. So, what should we do? We should always use vectorized operations. And why is it fast? Because we have this array elements, there are enough registers in the CPU, well not enough, but there are good number of registers in the CPU, and they come boom, it does like this, it is like a hardware tuck, it gives a result. So, it does it like that. So, it is fast, faster than loop. Loop also is vectorized, but not as efficient as A star B. A star B is efficient operation. Now, not only A star B, other things like sign of A or A plus B or division, all of it you can do it with vectorized. I want to exponentiate the array A stars are 3, that means every element will be cubed. Okay. So, that is one lesson we learned, that we should use vectorized operations not only in Python, but also in C, Fortran, we should do that. Now, just look at C, I am going to do it later, but I thought in the table I will put that number. C without any optimization 361 millisecond, and with different optimization you get the number. 155 is with O fast option, and Python is roughly similar number. Well, 155 is around 3 times faster, right. But okay, I will show you some other numbers which are close, but 3 times is not a great loss. If one line can do it, I will always prefer this 3 times. I can sacrifice it. Is your choice. Okay. The Python codes are typically 1/10 the size of C++ codes, and development also takes much shorter time. Now, let us look at some other operations. Storage. Okay, I am going to do now a 2D array. So, 2D array, how are they stored? So, 2D arrays are stored in Python and C is a row major format. Okay. Now, I am repeating it, but yeah, just for recording I am doing it. So, row major is, what is row major? So, these numbers are stored in the memory, no, and from memory it comes to cache. So, are they stored in this sequence or in this sequence? So, it turns out row major means that is sequenced for given row. You store all the columns first, then go to the next row, store the next all the columns, like that. For given row you collect all the column elements. So, the in memory it is going to be stored as 0, 1, 2, 3, 4, 5, like this. They are well, basically these are okay. Well, I am just numbered them as in the same order as the address. So, address is goes in, if you look at the axis I comma j, I write like this. So, j when I in the storage, j will be moving faster. So, this is 0 0, then a 0 1, a 0 2, that is how it is going to go. Okay. So, by the way, accessing is you can read I mean, if you know C already, these are done by pointers. So, 2D arrays is basically 1D array. So, with pointer it computes what is the address and it goes this way. Okay. So, 2D array or 3D array, they are all finally stressed in one line, and is how, I mean, you can compute address always by formula which is coded already in a CPU. Hardware does it calculation. Okay. So, I mean that is how it is. So, it is basically 1D array. So, no wonder 2D array of same size of same number of elements will take roughly same time as 1D array operation, right, because 2D array will be converted to 1D array. That is what we expect. And let us see the numbers now. Okay. I mean roughly, not there are some overheads, right. I mean the address has to be calculated. So, there are always some overheads, but you should get same order. So, these are the numbers. So, Python, well, I did in 2 ways. So, I think it is important to emphasize it here only. For some reason in a loop. So, question is how should I make the loop? So, should the row index should be an outer loop for I equal to 1 colon, well, I am not using a range, okay, and just for 0 to n x minus 1, for j 0 to n y minus 1, then a I comma j. Should I do this or flip the loop order? I could also do for j equal to this, then for I, a I comma j. So, which is faster? First one, right. Why? Because here for when I is 0, then j will take the elements. So, I am fixing I which is at 0, then j is increasing. So, the numbers are consecutive in the memory and it is brought to cache, it is also consecutive. However, if I do this, then for, so the numbers I need for computation are this a 1 comma 0. So, you see I is changing faster in this loop, and these are numbers are not consecutive in the memory. Okay. So, memory locations are, I mean this is at 0 location and this is the 5th location. So, I would have got 10 numbers, but I need only 0 and 5, fifth address, well 0 and 4th address, sorry, this is 0 and the 4th, and 8 and 12, something like that. Okay. So, you are wasting lot of numbers which you already loaded in RAM and in cache, well from RAM to cache, and that is a big loss. So, it turns out numbers in Python are not too different. These are the numbers in Python for, so these are the two codes for loops, and the vector operation I did not have enough space to write it, but the vector operation will be just sum A star B. So, it turns out I j and j I are the same numbers. I suspect interpreter is smart, is basically taking j I as I j. Okay. I do not know the code inside how it is implemented, but many times these are very smart interpreters, and they are just switching it. Okay. So, these are around 40 seconds and this is 45 seconds, number is not too big, the difference is not too big, but vector operation is 746 millisecond, which is comparable to what we got for 1D operation. 1D operation I got around 450 milliseconds. Okay. So, that is the number 473 millisecond. So, we get roughly same timing for 2D and 1D. Okay. And so, we will worry about C, but you can see the C numbers are not too far away from vector operation. Okay. So, this is, so Python is tending to be having reasonable speed compared to C++. Now, I can put a inside if statement. Sometimes you need it, sometimes you think you need it, but you can avoid it, but I just put by for illustration I put a if statement for the same array. Well, actually I made some changes. So, this is old code. So, I want sum put plus. If you want the same code, you should compare. So, tot. So, this is change in the Google Colab, but not here. So, I am incrementing total, but for when Aij is greater than half, by the way these numbers are all between 0 and 1, okay, they are random numbers between 0 and 1. So, if you greater than 0.5 then you do something, if it is less than 0.5 do something else, and I just wrote multiplied by some numbers. So, that I just want compiler not to be doing some trick to avoid my basically do something, so that it is going through loop, that is what I want it to do. Again I do not know for whatever reasons, well I think it is doing cleverly, but the number is not too bad, 62,000 millisecond, and this is around 37,000 or 38,000 millisecond. So, it is factor 2, which is significant for HPC, but it is not factor 10. Okay. So, it is doing some clever stuff for cache management, but there is a loss of factor 2. Now, let us do the sign operation, sign A. So, same thing, I am just summing it up, but instead of A star B I just take the array A, and for every element I compute sign and sum. Is that clear to everyone? So, I get a number tot. So, this is by loop and this is by vector. By loop the number is 92,000 and with vector it is 1313. Okay. So, again I mean something like 80 times speed up is there, 13 times it is of that order, okay. 70-80 times speed up we get for vectorization, and this number is more larger this time compared to A star B. Why is it larger than A star B? Sign has more operations, okay. Sign is in fact computed by series expansion. I am surprised that it can do it in basically roughly 3 times time. I expected more, but it is able to do it in 1313 in a single core. Now, we can do it the same thing for array, this for array 2D, and 2D number is with Python vector is 1141, which is roughly same as what we got for single array, right. Single array was 1313, but this will be a fluctuations. I mean, if you run it, you may get 12 or you may get 13 or you may get 900. So, there are significant fluctuations, but I just took the number from the output and put it here. but if I do not do a vector operation, I do a loop, then I get again 90,000 and 102,000 milliseconds. So, loop is to be avoided, that is what we learn from this exercise.